So what I wanted to look at is, could we apply AI on the edge? Could we have machine learning like you do with a camera that's able to tell you, this is a car, this is a pedestrian, they are within this proximity, this is moving in that direction, this is moving in the, you need now able to make a decision, right? So that was the fifth dimension. And that's why we were able to get a registered trademark on it, because it's not a real thing, right? But it was that thing of, people needed to rethink radar.
We're going through something absolutely historic.
Technologies across the board are growing exponentially.
It's a disruption that's going to completely redefine the way businesses compete.
In the next decade, we're going to lose 40% of today's Fortune 500 companies.
The exponential growth of computing is continuing.
AI is nowhere near its full potential.
Whether you like it or not, that the future cannot be stopped by anyone.
Welcome back to the Future Tech and Foresight podcast. I'm your AI host Marc Verbenkov's Deepfake avatar, and this is episode number 187. Autonomous vehicles are often portrayed as the ultimate expression of future mobility, offering promises of safety, efficiency, and massive economic transformation. But what's actually happening on the ground today? In this episode, we explore the business case for autonomous trucking and agriculture, the evolution of radar and sensor technology, and how incremental improvements in ADAS are paving the way for broader adoption. Barry shares insights from his journey working with major automakers and discusses how sensor software innovations, cost reduction, and data-driven smart city applications are changing the trajectory of the automotive industry. We also dive into the role Asia is playing in leading global adoption. Now a little about my guest. Barry Lunn is the founder and CEO of Previsio, the leading provider of low-cost advanced perception imaging radar that is reliable in all weather conditions, delivering solutions for safe, cost-effective, and scalable L3+ autonomy. Barry has over 2 decades experience as an entrepreneur and business leader in the imaging technology industry, serving as a founder, investor, director, and CEO of several companies, and has worked with defense contractors, space agencies, and multinationals. Hi there, Barry. Thank you so much for joining me today on the podcast to talk about something that we've talked about a bunch on the podcast before, but because of the whole AI craze over the last, what's it been, 2 years, we haven't touched on this in a while. So it's great to look again at autonomous vehicles and, of course, the sensors that are making them possible. So it's great to have you on today.
Thank you. Great to be here, Mark.
Yeah. So the first question that I ask all guests is, what was your journey, or was there a specific event? Like, how did you get involved in doing the work that you're up to right now?
Yeah, it's a funny one. My background definitely isn't in the autonomous vehicle space, that's for sure. I probably got dragged kicking and screaming into it. My focus, I've worked in the area of high frequency electronics for more than 20 years, which is primarily communications and radar will be the main applications, and really primarily in aerospace and defense, right? That's the industry and I love that industry, right? Especially the space industry. I'm a child of Apollo. So that was my fun, right? Working with NASA, European Space Agency, Chinese Space Agency, Japanese, all of the guys over the years. And we started putting the first 4D radars, right? So radars that could see the world in 3 dimensions plus Doppler, right? And range and velocity. We started putting those into space with some of those companies I mentioned. And then that brought us more into, like, as we scale the technology, obviously space is a certain size. We started bringing it more downstream and started seeing other applications like helicopter landing systems. So it made it really so more soldiers die from helicopter crashes than bullets in wars, especially in the Middle East. So we started looking at those problems and using our tech there. And that's actually how the autonomous industry came to us rather than us going to the autonomous industry. And pretty much everyone that was working on autonomy reached out to us. And initially, this is my previous company. Initially, we probably said no to all of them. And then one day, General Motors Cruise got on, and they kind of went, "Hey guys, we're doing an autonomous vehicle," I kind of went with the usual line of, "Guys, look, we don't think this tech is for you." And then they went, "Well, we call the Project Aerospace," and we went, "Okay, you might be serious." So we started looking, and so we put what I believe is one of the first 4D radars that was ever put on a vehicle. We did that in my previous company, and it was focused on the edge cases, right? And this is where they were having problems. So lidar is traditionally, on autonomous vehicles and in cameras and that. Problem with optical sensors like that is they don't really behave themselves in bad weather, right? And as an
Right.
Irishman, I know all about bad weather, right? So, and especially coming from the aero defense industry, I found it hilarious actually that they were testing all these vehicles in Arizona, this perfect optical environment. It's like for me, if I went to NASA and told them my technology would never work in space, but it was great on the ground, they'd laugh at me, right? And for me, this kind of made no sense. So that was kind of where I ended up in it. But the problem was those sensors were like $100,000, right? And we couldn't really see a path to scale. So I ended up selling the company because when you see a ceiling, it's a good time to sell, I always say, right? So we did, and that was great. And then I had a car crash again. I've had a few. We have a lot of crashes in Ireland, and I had a car crash, and like most people, I think, would go home, and recuperate and try and see how they. That night, I just started thinking about the problem and going, actually, this is a way more interesting problem. Could we have developed sensors that could have solved that car crash? And then I started looking at other ones, and then I got really deep into, and of course, discovered very quickly those edge cases that the autonomous industry was having problems with, like rain and snow and ice and all of those and lack of force. It was the same thing that led to car crashes, right? And if you think about it, if you just replicate the human, you're just going to replicate the same problem, no matter how much AI you throw at it, right? So for me, I go, oh, actually, suddenly this industry is interesting. What if we could solve car crashes? And then you get into it and you go, wow, 1.35 million people killed every year, 50 million more maimed. You see the cost of the global economy. And then I kind of went, this is interesting. So that's kind of how went at this. But of course, I knew the $100,000 price point is no good, right? So I started then looking at, well, what does the tech have to cost? And I figured under $100 was about right because at that time, automakers in general were now people weren't saying it at the time because they were kind of going, oh no, autonomous vehicles, people will pay whatever. That's nonsense, right? There's no margin in cars, right? So there was never going to be that space. So automakers were paying $50 for a radar. They probably want to pay $50 on a radar for a long time yet.
Right.
We started looking at that. I started looking at it first, and then I talked to the smart people, obviously. And I went back to my old team and I kind of pitched it to them, my thinking, and the real thinking was, could we move a ton of the things we've been doing into software and solve the problem in that way rather than being very hardware rich? And they kind of didn't think I was mad, so they quit what they were doing and joined me and a bunch of guys I had worked with on that program as well, some ex Carnegie Mellon robotics profs. I pitched it to them as well, and they kind of quit what they were doing and joined. And suddenly we had a company, right? So there's a very long answer to how I ended up here. But it was genuinely, it was that thing of like, I actually think, I'm delusional enough to believe we could eradicate car crashes. And then autonomy will take care of itself, right? That's kind of solving car crashes is autonomy, right? It's the car taking over when humans are bad, right? And so for me, I thought that was way more interesting and it got me out of bed for sure.
Excellent. Long answer, but I love it. Um, because it's been a while since I've touched on autonomous vehicles. So you already gave some statistics about the amount of people injured, which is, each time that I'm refreshed on statistics like that, yeah, it's ridiculous. Um, do you have a stat on the amount of money that's wasted, both insurance and the actual amount of vehicles that are destroyed? Like, is there a some rough estimate as to the amount of money that's wasted every year on car crashes?
Yeah, there's a couple of figures, and like all these big figures, right? It can vary,
Sure, sure.
huge amounts, but it's estimated between 2 to 5 trillion a year is
Jeez.
the global cost. It's up to 5% of GDP in some countries, right? Because it's the add-on, right? It's a compounding effect, right? Because it's not, as I say, it's not just the road deaths. It's the injuries, and of course, as the ambulance, everyone is involved, insurance industry. So it's nuts, right? So anywhere between 3 and 5% of your tax dollars essentially are getting spent on this problem. So it is a societal problem. And like as you said, the numbers, they're almost, I think it's because they're so big that that we just overlook them. You know, that kind of way. I mean, if you invented driving tomorrow, there's no way it would be legislated for. Imagine someone, and what the analogy I often make is, the Boeing 747 fell out of the sky this morning, another one fell out at lunchtime, and another one fell down in the afternoon. How many of us will be flying tomorrow? And if it continued and kept happening, but we all get into our cars.
Yeah.
You know, so it's a very strange and emotional space, and we tend to try and avoid all of that by just basically going, until the tech is ready, until it's proven, we'll just help you. We'll just make you a better driver, right? And I think that's the important way to go at this. And then slowly but surely, we have felt like everyone will come along with that. The driver, once I save your life as a driver, you won't feel so bad about me anymore. I won't be the guy that's going to take the trucker's job. I'm the guy who's going to save your life, right? And I think that's where they got it wrong in the industry, where they kind of came out and said, yeah, we're going to have autonomous everywhere and whatever. And they had no path to it. So then everyone got to say, I told you so. And can we believe these people, right? Whereas I think if you do the gentle nudge approach, and regulators are coming with it now, right? And you see some of the, like NHTSA's new rulings in the United States are incredibly progressive. That is basically, it's mandated in Europe now. You cannot sell a vehicle in Europe without some level of robotics in it. You just can't sell it here. And now that's going to happen from 2029 in the US, and even more stringent robotics. So for me, I think that's the approach.
Okay, really interesting. Maybe one point on that, you're saying this like the public has generally you're saying like public has a lack of faith in these AV creators. I mean, I remember, I think this was like before COVID happened. Elon Musk was saying, well, next year we'll have, level 5 autonomy and it'll be, perfect. So I think there's also these, expectations that are given to the public, these predictions, and they're never really fulfilled. Like when was the I can't remember the name of it, but it was the DARPA Grand Challenge. Was it like 2001 or something like that? Like it's, 2001,
Yeah,
2011. I can't remember.
couple, and then like 16 was a big one as well, where there was a success. And I know a bunch of the guys that worked on that, and that was using LiDAR. But again, that was a controlled environment, right? So it was
Very much.
level 4. It was even, you could say, level 3, right?
Mhm.
So and I think that's what everyone underestimated, that jump, and it can be a problem. It's like the progress bar, right? And you're downloading something from Microsoft, and it gets to 60, and it just gets stuck there, and you're going, this isn't a progress bar. That's what the levels of autonomy are like. We had these kind of level 0 to level 5, and they weren't meant to describe incremental steps when they came up with them, right? They were just meant to describe that's what's happening at this time. So when we got to level 2 autonomy from level 0 quite quickly, everyone thought, well, then we get to level 3, 4, right? And then 5 will just come. Whereas that gap from level 2 to level 3 is nuts. You're going from human in charge to robot in charge. That's a huge jump, right? That brings everyone in. That brings regulators, that brings insurers, that brings, everyone has a say in it. And other road users, naturally, right? It's not just, what you decide to put on your car. It's what you put on your car, affects me, right? So I think that was the underestimation. That being said, you have to, it was done for a reason. Autonomy was expensive. People needed to peddle this idea, because I worked in the industry. I'm not like declaiming and saying that, they were all at it, right? And they all knew it wasn't true. Everyone knew it wasn't true. I worked with people in those companies. They all knew they weren't going to be solving, autonomy next year and all the things they were putting out there. But that's what they needed to do to get the stock price up, or
Yeah,
to raise.
to get the investment in the space as well. Sure.
And yeah, which I think that's gone now. All right, there's still a bit of Tesla stuff, right? But otherwise, the rest of the market, no one goes on with that guff anymore, which is another reason why I kind of like the market more now.
Interesting. So would you say that the main challenge or hurdle to overcome are these technical limitations, or is it, as you were saying, all these different things? It's, regulation, it's public sentiment, it's all these things that are slowing down or not enabling this progress bar to go as forward as we all want it to.
No, it's because they haven't solved the problem.
Yeah.
Once you can prove and you have the data and you can solve the problem, regulators and insurers will come with you, right? Like of course they will, right? And if and I've always made this argument. It's very, very simple. When the data says the car is a better driver in this situation, I'll give you an example. I'm in the southwest of Ireland here, right? We test our vehicles in Shannon, right down by the airport. There is like fog constantly, right? We get a lot of fog and things like that. The cameras and me can see about 10, 15 meters in that, right? Our radar sensors can see 600 meters. Right?
Yeah, that's crazy.
Everything that moves, we can see it in 360 degrees. In that scenario, who should be driving? Like the data will tell you the car should be driving and not me, right? And I think that's what you have to build up. And that's where I refer to the edge cases, because autonomy is a bit of a trickster, right? And this is why I say I like the aerospace industry a lot, because in the aerospace industry, you have to start with the hardest problem. You have to prove, so to sell a semiconductor to the aerospace or defense industry, basically you have to prove it can work in the harshest conditions, literally burning out, millions of dollars worth of the chips just to show what's the limit and why and what's the failure rate and all of that, right? This in autonomy, this started the other way around, right? They started driving around in circles and things like this, and it's really easy to get to an impressive demo, right? So it's something you have to really watch out for. It's really easy to get to that. Okay, look at this, and you feel like, wow, the car is driving. It's doing 98% of the driving. Yeah, but guess what? That last 2% is brutal, and that last 2% is what's going to cause car crashes, and it's what's going to result in the tech being eradicated. So I think I'm most interested in the companies that are focused on the 2%, and to be fair, that's why you're seeing almost all automakers kind of going, yeah, we're focusing on really good level 2 ADAS, emergency braking, and for some vehicles we'll go level 3, but it'll be quite controlled rollout. And I think that to me is the pragmatic approach, while at the same time acknowledging Waymo've done it, right? Like, Waymo's superb, right? But it's level 4. It's in those controlled environments, and they're not being stupid either. Waymo aren't coming out making statements of this is going to be everywhere tomorrow, or we're going to, you don't hear Waymo saying we're going to license this to everybody, right?
Right.
Because they want to wait. They want, because they could do that, right? And that's a good thing about Waymo, that there's so much money, available to them, that they're able to resist that urge to say and do stupid things. And I think that's why they're a great benchmark for the industry. Actually, I think they're kind of, and I think working hand in, regulators will take notice of that. And I think slowly but surely, if it doesn't, walk and talk like a Waymo, it ain't going to be getting level 4 licenses. And at the same time, level 3 and level 2 now are pretty heavily regulated. So we know what will work. And I think that's only right. Anything that can kill people should be regulated. I know the US doesn't like regulation, right? But even there now, it has to be regulated.
Right. Okay, so that's for like urban vehicles that are, city, consumer vehicles. I've also heard a lot, and I've had a couple guests come on about autonomous trucking, which might seem, from what I've been told, and maybe you're a little bit more of an objective perspective here, that might be implemented before, because it's maybe a little bit simpler because you're just driving on highways, and the challenge, if I remember correctly, has to do a lot with sensors and being able to see, as you were saying, 600 meters ahead so that you can brake in time. That seemed to be one of the main limitations, if I'm remembering correctly.
Yeah, exactly. So we do a lot of work with trucking because we probably have some of the longest range sensors out there, right? Like detecting vehicles stably out to 600 meters in nasty conditions. I always have to preface it with that, right? Because there's no point in having a sensor that does it twice a week, right? That you have to be able to consistently do it over a 90% threshold and on a regular basis. So yeah, I think trucking as well, the business case is strong, right? Because there is a shortage of truck drivers, and so within the industry, there's a push there as well, right?
Right.
And the other side as well, in safety, I'm seeing in trucking, right? It's been much heavier regulation within that. So they're starting to put the sensors on there for safety, and then they're kind of going, well, hey, hang on, could we have a bit more automation then? So I think it's a good business case. I think, but you're right. I think the ranges, the ability to prove. So whether it gets there first, I think it's the first very clear value proposition for autonomy. It's really, really strong. I think the other one then is agriculture. And again, and then you get into heavy machinery, right? Like so for example, I find it really hard to get drivers in dumps, right? You'll be surprised. Not a lot of people want to drive those big machines in those toxic environments. You
Strange.
would have known, right?
Yeah.
So again, those are the kind of and there's also a cost proportion, right? If the vehicle is bigger and costs more money, then there's less sensitivity to the cost, so the sensors can get there a bit earlier, right? But again, it's about proving it because bigger machines can cause more trouble as well, right? So a truck going out of control or doing something it shouldn't is a hell of a lot more catastrophic than a motorcycle, right? So there's a lot. I think the business case is definitely strong, and that's leading to a continued investment. Whereas in the automotive space, it was easier just to tail back and for the automakers to go, hey, you know what? We're just going to focus on this. And the other big thing was the automakers, though, the business case is interesting there because when they survey people, people weren't looking for autonomy, right? But they love ADAS, advanced driver assistance systems. And it's one of the things people are prepared to pay for, and they're prepared to pay a subscription for, right? So all the automakers are constantly flying kites to find out where can we make money, right? Where could we have recurring revenue off our vehicles, right? Because that's traditionally something they haven't been able to do. And one of the few things, and it's like up on 80% of consumers are prepared to pay for more advanced driver assistance features, right? Things that allow you to just relax a bit more on a long drive, these kind of things. So that's leading to an interesting one as well, because now there's a business model there, right? So that's why they'll invest in more sensors on the vehicle and add that because people are prepared to pay. So like everything in life, it always comes back to the money. But I don't mind because if that leads to, and that's even on the safety side, especially when I talk to automakers and trucking companies and agricultural companies, I tend not to talk about the safety message. That's like our mission, right? That's what my team is doing it for and what we're interested in. But if I'm not in there talking to them at the cost level, so I have to go in and pitch to them and go, hey guys, here's what consumers are prepared to pay. You know that. We have the sensor that allows you to do that, and at the price point that you can do that. Then it's a much nicer conversation than, telling them they're selling cigarettes, right?
Right, right, right. Okay, maybe one last question here, and then I definitely want to get into what you guys are up to. This question is kind of rephrasing a little bit what you're saying, or repeating a little bit, just so that I can be clear. To me, it sounds like autonomous vehicles, or maybe not autonomous vehicles, but vehicles are going to get bits of autonomy added to them over time until we get to a full level 5, which we can talk about later on, but I don't think it's going to come next year. Right. So we're going to see these small improvements like this assisted driving, and maybe some other things down the line, kind of in a piecemeal way until the technology is actually there before the final implementation.
Absolutely.
Yeah.
Absolutely. And that's not even, will it be or making a prediction. Like automotive timescales are quite long, right? So pretty much every major OEM, I know their roadmap, right? And so does anyone in the sensors, right? And basically they've made all their decisions up to 28, 29, 27, 28, 29, essentially at this stage. So we know and you can tell by the sensors and software that's going on a vehicle is what that vehicle, don't believe the nonsense of we're going to turn it on later. That's not true, right? Like functional safety in all of the boring stuff that no one ever talks about means that just won't happen, right? So that those decisions are made, and now the kind of RFQs, the request for quotes and request for information are coming out for the 2030, 31. Those time horizons, those are still level 3, right? You're basically, so pretty much everyone up to 27, 28, 29 is level 2, with a sprinkling of level 3. And I mean a sprinkling, right? Like tiny. And then level 3, most people are starting to think of as a 30, 31, 32 type problem, because they have to get over certain safety regulations before they head into that. So really in the main automotive sector, which is, humongous, right? That where the mass number of vehicles are sold, that autonomy isn't even on their roadmap right now, right? And therefore, this idea that we'll have autonomy on our roads tomorrow or anything like that, or once someone gets over that level 5 thing, then everyone will get there. It's just not going to happen. It's a fantasy. So I would say, yeah, it's a friend of mine in the industry said it's always 10 years away, and I can't disagree with him on that. It's all, full autonomy, and but you are right. You do, it has to be general as well, right? Like before all of this will work, it has to be available to a lot more than, 2% of vehicles, right?
Yeah.
So I think, yeah, it's a bit off, and that's okay. I'm okay with that. I think, let's get there and get there safely. Whereas I do think you're just going to see, and the business model, way more proving the other business model. Again, I always go back to business models, because if the business model doesn't exist, the industry doesn't exist. It eventually gets found out. When we had free money a few years ago, you could have all these products without a business model. But then when reality bites again, is there a business model? Waymo, it's a business model, right? Uber exists, right? Lyft exists. Waymo, in the jurisdictions that they're in right now, have already started passing out Lyft in terms of number of rides, right? So proven business model. So that can scale, but we know the taxi market and the general automotive market are two completely different babies, right? So I think that's how you'll see, Waymo and these guys scaling very successfully. Because I would rather get in a Waymo than an Uber with a driver. I think most people would, and I'd pay a small premium for that, and their business model then works, right? Because the utilization of vehicles is so high. So I think wherever there's a business model, things will work out.
Very interesting. Okay, let's dive into what you guys are doing. So, you mentioned at the beginning of the episode, your previous company had a 4D sensor. Now you have a 5D sensor. Can you describe to me what 5D is?
Yeah, 5E is marketing. I pride myself on honesty, Mark, so I'm going with that out of the way straight away. And actually, it was a funny one. Back in, it was about February 19 that I had that car crash. And that the following day when I was drawing out this, and I literally wrote down 5D perception. And where it came from was it it was basically me. We had focused. It was very much a hardware problem we were solving with our 4D sensors, right? So we built the quietest radars, and so radars are noisy, right? You've probably seen, radar images on TV, and they're like blobs, and it's like, but they're really good, right? They know that the range of velocity is of that blob really well. So that's a good thing. But basically, they're not known for high fidelity imaging and that. What we were really good at was getting really good 3D images of objects. And then obviously every dot on that object, we knew the exact range of velocity, and that was that fourth dimension. The fifth piece was perception, right? The ability to understand what is it, right? And that is something radars didn't do. Cameras did it, right? So cameras were really good on that. You take Mobileye, that was Mobileye's edge, right? That they had the best AI, they had the best machine learning algorithms. So what I wanted to look at is, could we apply AI on the edge? Could we have machine learning like you do with a camera that's able to tell you, this is a car, this is a pedestrian, they are within this proximity, this is moving in that direction, this is moving in the, you need now able to make a decision, right? So that was the fifth dimension, and that's why we were able to get a registered trademark on it, because it's not a real thing, right? But it was that thing of people needed to rethink radar, right, and not just think of it as a range and velocity, because in most vehicles, radar basically is what gives you your adaptive cruise control, right? It's really good at knowing, whereas a camera is always guessing the range and velocity of something, right? It's like we do, right? When you go to turn out on a road, you look and you go, okay, that car is getting smaller at this pace. I think he's at, or getting larger, I should say. I think he's at this distance, right? That's what cameras do, right? They do the math, right? Whereas obviously a radar gives you Doppler and it tells you exactly that range and velocity. So adding all those things together, that was really the concept. And that's what I went out and pitched to my old mates was, if we move, because if you think about it, if you were able to move your development into software, now I'm able to run my algorithms, my machine learning, my AI. I'm able to run that on the radar sensor, on the data, the raw data coming off that radar. And that's going to change how people perceive radar. And that's really what we've been building for the last number of years.
Okay, so the only thing that comes to my mind, well, there's a couple things, but the main thing that comes to my mind, and maybe this is obsolete now, but I've heard Elon Musk talk about how he doesn't want to use radars or lidars. He's only going to be using cameras and then he's going to be boosting the Tesla's AI in order to understand all these things that you were just saying. Is that and I know that he's gotten pushback within the industry, competitors, etc., about is this feasible or not. To me, it sounds like you can get much more uh, relevant data for level 5 autonomy from sensors of the ones that you're describing, and it's going to be a little bit trickier to do that with these cameras.
Yeah. So nobody in the world believes you can do it with camera only. Absolutely nobody credible in automotive is talking about it. And you know who I include in that? Elon. Um, Guess who's building for their own 4D radars? Tesla.
See,
And
okay.
they have a full 4D radar. Their new hardware stack it has 4D radar in it, right? So
Hmm.
what happened with Elon? And Elon, by the way, always believed from the beginning that you needed radar and camera, right? Because
It's just a marketing stunt.
it was a bit more than that, right? And I got where he was coming from on LiDAR. Now, obviously, I would prefer, as a guy who's focused on safety, I prefer if there's LiDAR sensors on, they're great, right? But I'm also pragmatic enough to know that they're too expensive and they break, right? And they have to be calibrated. So the kind of things automakers hate. So everyone, again, going back to those I was telling you earlier about, knowing where all the OEMs are going, the car makers,
Hmm.
the guys who have adopted LiDAR are all talking to people like us about getting rid of it on their next gen, right? So
So interesting.
they've only just got it on and they want to take it off because it's problematic. It costs too much. It's everything they hate, right? It's costly and it breaks, right? So the automakers hate that. So that's an interesting one. So it's basically and the market right now is about, let's say in terms of just pure sensors, it's about 12 billion and it's about 50-50 radar camera, right? So it's radar camera is where this thing is going, right? And as I say, Tesla have their own 4D radar development because you actually can't even pass some of the new regulations for emergency braking without a radar, right? Like, so again, Elon doesn't believe that either. So it will be camera and radar. Really what it comes down to is how much of each doing, right? And for me, what we're trying to do is, so we have a vision team as well working on the camera side of things. But obviously, because we're a radar focused company, it's to see what the radar can do. And what we're trying to do is build a full driving stack using radar only. Then you have your full driving stack using camera only, right? And then you fuse the data, right? Which is really cool stuff, right? So you at a low level, you fuse your low level radar and camera data, and then you build a perception stack on that, right? So now I've got three things that are controlling my drive planning and control. And then I put my safety policy together and I go, okay, in what situations which one's on top, right? Which one's on top in what situations? And there are some scenarios where cameras are absolutely brilliant, and there's things cameras can do that radar can never do, right? Like, the radar's never going to read a road sign. It's never going to know whether the light's green or blue. It can't take the lines off the road or those type of things, right? But then radars are really good at a lot of things cameras suck at, right? And especially in weather conditions, again, getting rid of the guesswork and the computational load as well. Cameras have a huge computational load. So again, if you can remove that by just using 360-degree radar, it's a no-brainer, right? So what you're kind of seeing in the industry is, as people move to level 2 and beyond, they're going from, right now, most vehicles have a single forward-facing radar and a camera, and then the rest is just for parking, right? Um, and really, we're moving from that to being 360-degree camera, 360-degree radar. So pretty much all the newer vehicles, especially in the higher end, are all going to have 5 to 6 radars now. So 4 corner radars, a rear radar, and a forward facing, and fusing all that together to get this really nice point cloud. Then the piece is, at the forward face, some are adopting LiDAR, right? And I think that's what you will see, especially with companies who've concerns around safety, the Volvos, the Mercedes, who've built a reputation around safety. You will see, until the data proves they don't need the LiDAR, they'll still adopt it if you want level 3 plus, that kind of way. But as soon as the data says, hey, you don't need it, well, then you can take it off. And that's how I see the world, right? If the data says, whereas if Elon was able to show the data, if he was able to deliver, a level 4 vehicle, in any kind of a scenario with camera only, great. But, and by the way, why that happened was during COVID, they weren't able to get radars, right? So he had a supply problem. So
Right.
basically, he said, "Oh, gee, you can do it with camera only," or else he had to stop selling vehicles, right, or stop selling that software. So that's where that came from.
Okay, interesting. Um, so we have a little bit of time left, but typically what I like to do in the later half or the later section of the podcast is talk a little bit about the future of whatever technology or impacts we're going to talk about. Um, so you're discussing about all of this extra data that both the radars and the cameras are going to be taking because it's 360 compared to what it is now. Are there any like second order effects that happen from that? Like apart from enabling autonomous vehicles, you're collecting all this data about the city or the area that you're in. Are there, you know, other businesses that can take that business to benefit some aspect of society, improve something, have some sort of impacts apart from autonomous vehicles that we're talking about? I don't want to, take the conversation too far away, but I think that this is an interesting point to bring up right now.
It's a very interesting point, and something I believe in, but it will only happen with regulation. And for me, the data we collect should be open sourced, is how I look at it, right? So if we go back to Mobileye, and because they're kind of one of the most successful, we'll say, machine learning AI on the edge companies in the world, they pretty much have a map of the entire world, right? And that's their business model, and they own that, right? And basically, if you design Mobileye chips into your cameras, you get that data. If you don't, you don't. And by the way, Mobileye used to work with Tesla until Tesla couldn't get that data, or Mobileye became uncomfortable with what Tesla was going to do with the data, and they had to separate, right? And then Elon wanted to own it. For me, I think it'd be fantastic if all the automakers could come together and go, hey, let's pool the data, let's pool this resource, because I think it becomes an extremely valuable human resource at that stage, right? To have a map of the entire world, right? Because there's interesting things, and what otherwise will happen is, because data is expensive, right? And so that for me is the hope, that there'll be so much data that the only way to do it will be to monetize it, or open source it to that level, whereby you start upselling it to other people. So I think that's a really interesting one, because it's smart cities and things like that. Because once you start, and we do a lot of work with smart cities companies using our sensors in fixed environments, right? And again, that data is really interesting. So it's one thing if I have the data coming off my vehicle, But what if I had the data coming off every other vehicle and I had all the data coming from the city, from the intersections and things like that? So there's a lot of V2V, V2X, all that kind of stuff happening. And I think that's where you'll get that second order effect where you start to go, okay, this is how we're going to manage traffic, right? And this is how we're going to manage flow, right? Because intersections don't have to be the way intersections are, right? But I think that will have to come from regulation. In other words, you want to use this, and I think the smart cities thing is when cities will realize what they have. And the Japanese are doing some really cool stuff on this side of things, and it's being centrally funded, which I think is quite interesting. So I think once people start to see that and see how that data becomes interesting, and if it allows an automaker to get somewhere else, they'll all start, I think, sharing the data, because the rule should be, you want this data, you got to share yours, right? That's how I look at it. And when I say open sourcing, that's what I mean, right? I don't believe in just like, giving away data because it's expensive, right? And it's gold. But yeah, so I think those are the kind of second order effects, which I think will be really interesting. And it'll be really, and by the way, where I'd love to get to with tech like ours, right, is that cities become nicer places without cars. Like, sure, it's going to shock you. I hate cars, right? In- I don't like cars.
Yeah.
I don't like cars in my city. I don't. I've seen the benefit. I lived in Vienna a couple of years ago for a couple of years with my kids, and like Vienna always comes out on top of all these indices of best places to live. One of the big reasons for that is like cars are down the list in terms of priority and what the government. If you want to drive in Vienna, it's a pain in the ass because everything else gets priority. Pedestrians are top of the pile. Then it goes that, and then it's public transport, right? And it's cyclists, sorry, and then public transport. So that to me is utopia. That's where we want to get to. And I think this is what this technology will allow all of that, right? Because I saw it myself in using. I didn't own a vehicle. When I moved to Vienna, we went from a two-car household in Ireland to a no-car household in Vienna, and we were using car sharing at the beginning, right? And it was incredible just watching how quickly we stopped using the car share. You know what I mean? It just dropped off completely, and literally the only time we ever took a car was when we were going skiing, right? Which we took a car and went skiing, and if we could get a train, we'd have got a train. And I think that's when you bring in these autonomous levels, it just the whole world becomes a taxi, right? And I think that becomes an awful lot more interesting. We'll have nicer cities and towns, and and living in the countryside as I do will become a lot nicer as well.
That's really interesting. I've spent my life, I'd say maybe not half, but half inside of Canada and half outside, roughly. Um, and I've spent a lot of time in Europe and a lot of time in Latin America for the most part. Those are kind of like the three big places. And yeah, very, very different, like different universes in many respects. And this idea of like not owning a car out here, like I'm also out in a little bit of the countryside in Canada, and it's impossible to get around without a car, right? There's no trains, there's no public transport. Like you need a vehicle. You can't bike anywhere because it's too far. Compared to Europe, right? I also didn't own a vehicle, and it was lovely to be able to walk everywhere, bike. I had a little electric scooter at some point, um, and I think that this maybe also looking at the time here, one of the final questions: how do you and your industry think about autonomous vehicles in different parts of the world, right? So I know that you're in Europe, and I think most of the market I mean, maybe actually correct me if I'm wrong, but most of the market for your sensors is going to be Europe and North America. Maybe not so much Latin America or uh, you know, parts of Asia or something like that, where I haven't been, but I've seen, certainly the craziest intersections are over there. Um, do you think that these impacts that we're talking about, second order impacts, autonomous vehicles, are going to be feasible to be moved over there, or is that, not 10 years away constantly, but 15, 20 years away?
It's interesting, actually, when it comes to broader thinking. Um, Asia's pretty strong in that, right? So you're right. Europe, obviously, and especially in the sensors type market, is very strong, right? The biggest companies in the world like Bosch, Continental, that are here, and then North America as well is growing, especially on the more autonomous side. That's where the investment has gone. But then you get to Asia, right? And you look at Japan, right? And obviously Japan is one of the biggest automotive markets, but also on the sensor side. And then China, right? Like China is just huge. And then Korea, right? So when you actually go to where we sell sensors, right? We sell them in all those jurisdictions right now, right? And in terms of the smart city and the thinking more broadly about the sensor types, I would say China, Korea, and Japan are streets ahead of what we're seeing in Europe and the US in that regard, because it's just a different a different way of thinking there, and also they can do more cathedral thinking, right? They think in longer terms, right? If you're going to be in power in China for a long time, you can make long term decisions, right? And I've seen the benefits. So I used to live in China, and I saw the benefit of that. Like I saw the transformation of Shenzhen when I was lucky enough to be there when the underground opened, and I saw how that city went from being a Wild West into something that was just felt completely different, and it changed the whole city to the point where the city center moved. They moved the city center because the connectivity just made it make more sense, and everything worked, and they can do that. So I think that's where and when it works there, and one thing that Chinese especially are very good at is commoditizing technologies, right? And therefore, once something becomes commoditized, a bit like electric vehicles, right? Price comes down, and then it becomes, well, everyone has it, right? So I think that actually that part of Asia is very, very interesting. But one of the places that we get a lot of interest from is India. And the reason for that is they've tried cameras, right, in India, and it hasn't been particularly successful because cameras are good in quite linear environments, where you can see road markings and you can read the road signs. I'm sure you haven't maybe been to India, but if you've seen it, right?
Yeah.
And also, most of the roads, once you go off out of the cities, there's no road markings, and there's a lot of. It's extremely hard training a neural net in camera that can adapt to those scenarios. Whereas radar, they're seeing and going, oh, hang on. Well, radar, it doesn't matter whether it's a horse or a cow or whatever. It'll tell you there's a damn thing in front of you and you better stop, right? And that's something that, so we are seeing an awful lot of interest, especially when we can hit the price point. Because I think that's the big thing, right? Like the big thing is the price point. Can you get it below $50, right? And when you hit that, then those other markets open up. But we do have in Latin America, a place like that, we see a lot of the interest is more around automating agriculture in those spaces, automating the mining type industries, these type. So we certainly see an awful lot of interest from those type of applications more worldwide. But so I think it's funny one. If I was betting on who'll get there long term, I would say Asia will definitely do it before Europe and North America.
Okay. Interesting. Yeah, I wasn't considering, I guess those big three, but like I have a couple people on my team from like Bangladesh, and I've seen some of the transportation videos that they've sent me, and it's like, okay, there's like level 5 automations a ways away for some of those places.
And it's fantastic, and they're so open about it. Like we do a lot of work with Jaguar Land Rover, and these guys is quite public, and so Tata is the parent there, and we've had some fantastic conversations with the Tata guys, and that sent videos and goes, yeah, well, how would you deal with this? You know what I mean?
Yeah.
And really, for me, I just think those are as I said, I'm obsessed with the big problem and the edge cases. So I'd love to deploy something there and see how it goes, and obviously with all the safety measures in place. But yeah, I think those are the really interesting spaces.
Yeah. Interesting. Well, we'll have to see how the future unfolds and see what happens in those countries there. Yeah, very very interesting stuff. Barry, I see our time is pretty much up here. I wanted to ask you a question about, you know, bringing down the cost of your sensors and, how AI is involved in that. I don't know if you want to spend a couple minutes on that, and then we can wrap things up.
Yeah, sure. So actually, two things that had nothing to do with me happened that made me found Provisio as well. Let's at a crack and having a mission, right? The first was we got millimeter waves, which is where we operate high frequency electronic. We got them onto silicon, right? Like, so that happened, right? And when you get something like that onto silicon, what used to be all analog now could be analog and digital in the same place, right? So that was a huge step, right? So now we describe our technology like a software defined antenna, right? You couldn't do that if you weren't able to mix your digital and your and your analog together, right? That was one thing. The other was GPUs. So we'd started working with NVIDIA back on those programs some years ago, and we could see the scaling and what they were allowing, right? So actually, one of the things, the reason for that fifth dimension was that ability. Okay, now I have my analog and digital and my GPU all in the same house. That means I can AI, machine learning can start to have a role on my analog. That changes the sensor completely, right? And that what that allowed us to do, and so they weren't anything we didn't develop those technologies, but then we were able to move what we had done in analog, move it into digital very quickly, right? And that's what's really allowed us to reduce that cost. So stuff we all had to do, if you think about it, things we had to do with, I had 78 chips in that $100,000 sensor, right? I can outperform that with a single chip today, right?
Right.
That's what's the difference, right? And so we can now outperform that $100,000 sensor for less than $50 because we were able to move all that technology into digital. And I think that's really, and then you're running your neural nets on that, which means we always say, like, people, traditional radars come with a data sheet, right? And that's what it does forevermore, right? And it gives you tracklets and it tells you this is a range and velocity, blah, 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 right? We nowadays, our radar sensor comes to you, that's the worst it will ever perform, right? It keeps getting better. And not just, things like, oh, it's better at perception, it's better at separating objects. Like, we send software over the air updates to customers that have doubled the range of the sensor, right?
Wow.
We're increasing the angular resolution on the sensor by 2 and 3x with software updates, right? Because we have all that mixed. That's what's allowed it to get to that kind of a price point, is that, and that compounds then, right? So if you want something then higher end, okay, it goes to $100, but you're talking about it's competing with an $800 LiDAR, right? At that performance. So that's really what's allowing this to get to scale. Because, and the other thing is, as you can imagine, now my size is smaller and my weight is lower, my power consumption is lower, right? So so I can do what traditional radar companies are doing with 6 chips, we can do with 1. So you can imagine the effect that has on the power draw. So I think that's why we'll win. Because if you don't solve that trade-off, you don't win in this industry, right? It is, I'm a big believer in history tells us the future, right? And we know, everyone keeps coming along saying, no, when they see how good our sensor is, and I'm going, nope, they won't. They won't pay more than $100, so forget about it. So we're kind of, that's how we're looking at the world. Solve those two problems, and we've seen the transformation. Even, when we first showed our sensors, people were like, "Wow, that's amazing what you can do." But now the story is, yeah, and we can do it for $50. Now that conversation is very different. Now it's like, okay, how do we get it on the vehicle?
Right. Right. Yeah. Then it's not even a question of limitations or any kind of negotiations. It's just, well, let's adopt this, implement it, and make our vehicles better.
Yep.
Very interesting. Barry, I think our time is up here. Thank you so much for coming on to the podcast. I will have Provisio, your website, up on the show notes, your LinkedIn. Are there any other places that you want people to reach out, follow what you're doing, etc.?
No, it's good. We're pretty active on LinkedIn, so it's a good spot to keep up with what we're doing. So yeah, that's really good, and we're updating our website as well soon, because a bit like our sensors, our website is out of date the day we put it up, so we'll be updating that all the time. But yeah, LinkedIn is a really good spot. We got good social media guys doing good stuff up there.
Perfect. Well, thank you so much for coming on. It was It was great to have autonomous vehicles and sensors kind of refreshed in my mind. And I'm certainly thinking it's going to be the same for a lot of people in the audience. So thanks again for your time.
Awesome. Thanks, Mark.
Appreciate it. Well, thanks for listening to this week's Future Tech and Foresight podcast. If you like what you've heard here, there are, of course, a number of ways that you can support the podcast. The best way would be to leave a review on Apple Podcasts or give a rating on Spotify, which you can find a step-by-step explanation for on the futuretechandforesight.com website. Alternatively, feel free to leave a comment either on the episode show notes or the YouTube channel where you can see video recordings of the interviews. And finally, if you are part of an organization that is aware of the disruptive and transformational impact that emerging and future technologies will bring and want to know more, please get in touch to hear about the strategic foresight services that we offer and how we can help future-proof your organization and take advantage of the phenomenal opportunities available to survive and thrive in the future.
A lot of future-shocked people and future-shocked institutions in our society are simply overwhelmed.
Once there is superintelligence, the fate of humanity may depend on what the superintelligence does.
Science fact is catching up to science fiction.
The first truly intelligent machine will be the last invention that humanity needs to make.
The only scarcity that will exist in the future is that which we decide to create ourselves as humans.
Within a 10-year design revolution, we can have all humanity living the highest standard of living anybody's ever known.
Progress is accelerating at an exponential pace, and it's going to reach a point where progress is so fast it's going to be a singularity.
We are probably one of the last generations of Homo sapiens.
Every single headline points to the birth pangs of a Type 1 civilization.